Hi everyone, let's get started, because I don't want to run out of time, and I have a lot of slides. Can you all hear me okay? Yeah, okay. So my name is Marko Lukša. Most of you know me. I'm a software engineer at Red Hat. I used to work on Kubernetes and OpenShift. Now I mostly work on Istio. I'm the author of the Kubernetes in Action book. There's a free book that's basically chapters 2 to 5 from my big book are available freely in the Exploring Kubernetes book, so you're welcome to come get it. This is the URL. I need to know some things about you so I can know what to talk about and what to skip. So how many of you are developing microservices? Okay, heard of Istio? Okay, the guys who are doing microservices mostly, right? Using Kubernetes? Nice, I like to see that. So let's start off. So you probably saw this on Twitter or whatever, Facebook, I don't know. So yeah, ideally we'd like to have software like this, but we usually end up having software like that, right? So microservices are supposed to solve at least one part of that, right? So by having smaller, simpler units, there's a lot less coupling, much prettier code, and so on. Because so if there's a strict boundary between two modules, let's say two microservices, it's obviously much harder to use the other service improperly because you have an API in between, whereas in a monolithic application, you basically can always call the other module directly. Okay, Java modules solve that, but yeah, this is fairly new. So microservices allow you to develop in different languages, the most appropriate language for each microservice. You can reuse existing components written by other companies, open source, and so on. And most importantly, you have independent development cycles for each component, and obviously release cycles and so on. And not to mention the last thing that is independent scaling, which is usually a good thing. But in reality, these are the problems that you'll face when doing microservices. So you need to keep in mind that, is there a laser here? No. No. Basically, previously when you had a monolithic application, you did not have any network calls in between your modules, whereas in microservices, there's network between the modules. So basically, the network can fail either permanently or intermittently, and you're going to have problems, right? Or you can just have network latencies, and these are just also things that you don't run into when you have a monolithic application. So, and another thing is obviously like man-in-the-middle attacks, because now the components are communicating with each other through the network, so basically they are vulnerable to attacks, right? And when a user uses your application, if there's any kind of problem, you basically do not know where that problem originates from, right? It could be it could be this microservice or something, and the user sees it here, so you need a mechanism to figure out where the problem is, right? And in reality, in production, you do have multiple versions of the same microservice running, at least while you are doing the upgrade, or maybe for canary deployments or A/B testing or so on. So basically, this is the reality that you are facing when doing microservices. And in order to properly manage such a system, you need to have distributed monitoring and distributed logging, which all send the logs and metrics to a central location so you can analyze them. So basically, this is the reality. Istio is an open source project that is supposed to solve most of these problems. So it's an open source service mesh. What's a service mesh? Is a decentralized application networking infrastructure that connects your microservices. So basically, sort of like Kubernetes, but it brings additional stuff on top of Kubernetes. So Istio is not a library that you need to import. You don't need to modify your code. and it's completely transparent to your application. Basically, it's in between your microservices, right? So sounds impossible that you can have all this without actually requiring any changes to your application. Well, that is why I call it magic between your microservices. So usually I start off explaining what a product or a system does. This time I'm going to do something differently. I'm going to explain how it does it because it's magic. It feels like magic. And then we're going to take a look at what actually it can do. So basically Kubernetes, so Istio can run on top of Kubernetes, but it can also run standalone. So if you're not using Kubernetes, you can still use Istio, but we're going to focus on using it on top of Kubernetes. So Kubernetes introduced it introduced a bunch of new patterns. One of them is the sidecar container pattern, where basically instead of adding a library into your application, you run an additional process close to your application process, and that process improves your application, right? Often without the main application's knowledge. So that's the crucial part here. So basically you have your service, microservice, basically your code. In Kubernetes, it's running inside a pod, and you can add a sidecar to your service. And in the case of Istio, that is the Istio proxy. Well, actually, it's the Envoy proxy, which Istio just configures, right? So Envoy proxy is basically another project. It's implemented in C, so it's really fast. So what does the Istio proxy do to your application, right? So let's say we have an external request coming into your service. What Istio does is basically reroutes the connection from the service to the proxy transparently, right? So your application does not know that this happened, right? So the Istio proxy is the one accepting the connection, and it then forwards the connection, basically opens a new connection to your service. And then the response, if it's an, let's say, HTTP application, goes back through the proxy, obviously, right? When we have two services that talk to each other, it's basically the same thing. Well, slightly different. So when service A tries to call service B, the outgoing connection is going to get redirected to the Istio proxy inside the pod A, right? So the Istio proxy then opens a connection to service B, right? But in reality, it gets redirected back to the other Istio proxy, right? And it is then the one that calls service B, right? So sounds complicated, but this is what enables Istio to give you the magic that it can, right? And in the same way, when service B, for example, tries to access an external service, let's say somewhere in the internet, again, the connection gets redirected to Istio proxy, and the proxy is the one doing the actual connection. So the Istio Service Mesh architecture thus looks like this. So instead of services talking to one another, they are actually talking through the proxies, right? So there are no direct connections between the services. Everything goes through the proxy. And each proxy talks to its own service inside the same pod, right? Of course, multiple protocols are supported: HTTP 1.2, gRPC, TCP, and so on. So up until now, we only saw the proxy, but so that is part of the so-called data plane, where the data flows, right? And we also have the control plane. You don't need to concern yourself with the actual components, but basically the control plane makes sure that the proxies are configured properly. It makes sure that the proxies get proper certificates for TLS and so on. And they also collect metrics data and whatever needs to be collected from the Istio proxies, right? So that was the how it does it. Now let's talk about what that actually enables, right? So Istio, first of all, it enables observability. So basically, if you have Istio installed, monitoring your applications is incredibly simple because you just get it out of the box, right? So because communication all the communication between your services goes through the proxy. The proxies can then send that data to the control plane, and the control plane gives it to Prometheus, which is a monitoring solution, and Grafana, which is basically a web UI that visualizes your metrics, right? So no changes to your apps, and you get monitoring for free. Yeah, this is what you get. So the next thing that Istio enables is distributed tracing. How many of you know what that is? The microservices guys? Okay. So, so for those that know and those that don't know, does that sound like something really complex, like hard to do? Or is it something really simple? So complex? Simple? Okay. Most of you voted for complex. But actually, distributed tracing is not a big deal. It's basically just passing some headers, some, let's say, HTTP headers around and recording some data to capture the progress of your work, so the progress of your program, of your execution, and so on. So in Istio, distributed tracing is enabled because the communication does not go from between the services. It goes, oh, sorry. Wanted to say something different here. So basically, let's say you have an application, microservices architecture, obviously, where there's something wrong with it, right? So there's some kind of latency. You're not sure where it is. So it could be here. It could be inside service A. It could be between the two services, inside service B. So basically, it could be anywhere. And because in Istio, all the communication goes through the proxies, we basically can trace the communication, right? We know how much time was spent inside each proxy, inside each service, between the proxies, and so on. Because all this data goes into the Istio control plane and then goes into some type of tracing tool. One of those is Jaeger, for example, and it allows you to visualize your spans. So traces, actually. So this is an example of a trace. So all this is one trace, so basically one request that came into your application, whereas these are so-called spans, and they just show you the amount of time spent inside each component, right? For instance, this is the main microservice, the product page, which calls the details microservice, and it also calls the reviews microservice, which then calls the ratings microservice. And you can see the time spent in each call, right? And you have 2 times for each call, the client side time and the server side time, right? So basically, when the client calls a service, you get the whole time measured, and when the actual request goes into this sub-service, right, you also get the time spent inside that service. So basically, you get monitoring, you get tracing. This is what we said so far, right? So the other thing you get is you get nice visualizations of your microservices. So this doesn't show you the relationships between your services, right? You just see that you have 6 services, different versions of one service, and so on. So it's hard to know what exactly is going on. But from the data that is gathered by the proxies, Istio, well, actually an external tool, Istio can give that data to an external tool, which can then show you the structure of your system, right? So in this case, we have the product page that's calling the reviews service. We have 3 versions of the reviews service, and 2 of them called the ratings service. We have 1 version of that, right? So really nice. I didn't need to draw this. This was generated automatically when I just ran my application. This is what I got. But Istio doesn't just enable us to observe traffic, right? It also allows us to control it or shape it. So those of you who know Kubernetes, you know we have services, and all the apps, all the instances of your app running inside that service get an equal amount of requests, right? So in this case, we have 5 pods. We have an equally split. So the requests get equally split among the 5 pods, right? In Istio introduces another resource, Kubernetes resource, called destination rule, which allows you to specify subsets inside the service, right? So in this case, we've defined two subsets, so subset V1 and V2, and we have two different versions of the application running inside the same service, so exposed as the same service, right? And when we do that, nothing changes because the requests still get distributed equally among the 5 pods. But as soon as we, introduce another resource called virtual service, we can specify how much of the traffic should go to one version, how much of the traffic should go to the other version, right? By percentages, right? For this case, we have 90% going to version V1 and only 10% to version V2. That is the so-called canary deployment. But in Kubernetes, you would have to, let's say if you wanted just 1% of your traffic to go to the newer version, you would have to deploy 99 old pods and 1 new pod, right? And that doesn't make sense in smaller applications, for instance. But with Istio, you can easily just specify the percentage, and you can only have 1 V2 pod and, let's say, 3 V1 pods, and it's going to work properly. So an example of a canary deployment in Istio is also this. So instead of letting 1% of traffic go to the new version, you can just allow, so the users that have a special header set, for example, the opt-in equals beta, those users will get routed to the beta version, right? So a normal request when it comes into your service is going to go to the production version, that is version V1, and if the request contains the opt-in equals beta HTTP header, it's going to get redirected to the other subset, right? So this is easily described by just one single, basically YAML file, YAML declaration, which you post to Kubernetes and then gets picked up by Istio. Dark launches. So probably most of you don't know what that is, so who knows what a dark launch is or traffic mirroring. Okay, this is microservices, guys. Well, some of them. So basically, this is something I like really a lot about Istio. So let's say you have a version V1, production-ready version running in your system, clients. Okay, and you would like to see how the next version is going to behave, right? Let's say that the version 2-alpha, because it's an alpha version. You don't want users to see it yet. You just want to see how it performs, for example, right? Let's say maybe you've improved it, so you expect the new version to require, let's say, 30%, 33% less pods to process the same amount of traffic as the old version. So instead of having 3 pods, you expect to only require 2 pods, right? But how do you test this, right? How do you confirm that your new version actually does this? So you can do it with a virtual service by basically using traffic mirroring. So by specifying that I want all the traffic that goes into my service, I want it to be sent to subset V1, but I want it to also be sent to subset V2 alpha at the same time, right? So sort of strange, but let's see what actually happens. So basically when a HTTP request comes into the service, it's going to basically get cloned and sent to both services, right? Version V1 and version V2. But then the response back to the client only gets back from version V1, which is the production-ready version, and the response from version V2 alpha is discarded, right? So this is awesome because it helps you to figure out if your application, if your new version is working properly, if it's performing well, and so on. So without affecting the clients, obviously. So I basically love this. This is perfect, right? Okay, I'm going really fast because there's a lot of magic here, right? So okay. let's put traffic management aside and let's switch to securing your communication. You probably know this already because you've been listening to this talk. Oh, let's start with this. So basically a man-in-the-middle attack. This is just to relax you. So because microservices are distributed, you have network communications between them. You are vulnerable to man-in-the-middle attacks. So you need to protect from that, right? So with Istio, it's incredibly easy because the services are no longer talking to each other, but through the Istio proxy, right? If you specify an object called destination rule and specify that the traffic policies should be, TLS should be set to Istio mutual, that is all you need to do. So basically 3 lines of code and your communication between service A and service B is protected by TLS, not just TLS, but mutual TLS. Who knows what mutual TLS is? Okay, some of you. So mutual TLS is basically, you probably have online banking systems where you need to have a certificate to authenticate, right? Is that so in Croatia? Yeah, okay. So basically that's it, right? So basically the client, when it talks to the server, it's not just the server serving the certificate, so the client knows that it's actually talking to the server, to the proper server, right? It's also the client serving so giving the certificate to the server so that the server knows that the client is actually allowed to talk to it, and it's so the client is authenticated without using usernames, passwords, and so on, right? So that's mutual TLS, and basically by using those 3 lines, all your communication in the service mesh is protected by mutual TLS. Awesome, right? And you can also specify RBAC, so role-based access control per service, right? So you can specify that service A is allowed to call service B, whereas service C is not allowed to talk to it, right? Okay. Okay. I think that's the thing, one before the last one. So Istio can also add fault tolerance, retries, and rate limiting to your services. Again, because all the communication is going through the proxy, it's easy to modify or introduce, let's say, circuit breakers or connection timeouts and retries, whatever you want, right? So in this case, Istio, or basically the Envoy proxy, can time out the connection. So if the connection doesn't succeed, it can retry the connection, and you don't need to implement that code in your service, right? So you do not need to implement connection retries in your service. You just let Istio do it, right? And it's, again, 4 lines of YAML code to specify that you would like to have 5 attempts, 5 retries, and 2 seconds per 1 try, right? The same way you can also specify, you can specify that you want to have a connection pool from one service to the other, right? You can specify that the service can only take, let's say, 200 connections at the same time, right? So by specifying the maximum connections, Istio is going to take care of that, and it's not going to open additional connections to the backend service, to service B, so thereby protecting your system from failures because the service B doesn't get overwhelmed with requests or connections, right? And also you can specify that you want to have a circuit breaker installed. So let's say service A calls service B, and let's say that service B gets overwhelmed or something, right? Or maybe just stops functioning properly. So if it returns 3 errors so 3 consecutive errors in 5 minutes, that particular pod, that particular instance of the service gets thrown out, and for 10 minutes, right? So 10 minutes, it's not going to get any new requests. All the other instances are going to get the requests, whereas this one is allowed to get its shit together and start working properly again, right? So, and one final thing that Istio gives you is it allows you to test your system properly by injecting faults and delays into your communication. I know. So for instance, when you're doing your testing of your whole system, you can insert delays into your communication without changing code, right? Just by adding 4 lines of code, 4 lines of YAML. So in this case, in 50% of requests, there's going to be a 3-second delay introduced in the communication, right? So you can then test how service A behaves when there's a network latency between service A and service B, right? In the same way, you can also inject a fault. So make service B return an error, and then see if service A is able to handle that error. Again, services do not know anything about this. That's the greatest thing about all this, right? You get a few things more, like URL rewrites. You can inject HTTP headers, whatever you can think of, basically. Because if you're aware that all the communication then goes through the proxy, if you can modify it, then why not, right? So yeah. Time for demo. Let's do demo. Let's do the demo, yeah. It's going to be a quick one just to show you. So I have the 5 pods, or 6 pods. Nothing interesting. So let's start with Kiali. Kiali is the microservice visualization tool, right? So in this case, the graph is empty. Let's start producing some traffic. Or no, let's do this. So this is my application. It's a bookstore application. On the left, we see the details. So this comes from the details microservice. We have the reviews, and we have 3 versions of reviews currently running. The first version doesn't show the stars. The second one shows black stars. And the version V3 shows red stars. As you can see, each time I refresh, I hit a different version. That's because I'm not using Istio at this point. I'm just using Kubernetes, and it does round robin across all the pods, right? So, and if I check the Kiali console now, yeah, so this is my microservice system. You can see the structure. And if I start hitting it with, where is it? Shit. If I start hitting it with a bunch of requests, it should start showing the traffic flow between the microservices. But because this is fetching the last minute every 15 seconds, it does take a while before it starts running. So in the meantime, let me show you the, let's say I wanted to split traffic. So traffic to the reviews microservice, I'd like to split it 80-20, right? 80% to version V2, 20% to version V3. It's still not refreshing, come on. As soon as I apply this file, it should start, come on. Is 1 minute over or not? Probably not. Come on. I'm just going to apply it no matter what. The reviews 80-20. So I now have. Yeah, okay, exactly. So if I now keep refreshing, I never hit the V1 version, which is without the stars, right? I get 8 times, so 80% of the time I get black stars, and then I should get red stars, although it's not happening. Oh, here it is, yeah. So it's about 20% of the time, right? Yeah, no, not really, because it's going fast and I'm going fast, so interesting that it doesn't start showing. So, or did I? Oh, yeah, you have to turn it on. So let's see. So Yeah, about 80% of the requests go to version 2, 20% goes to version 3. So this is it. And I can now change, edit virtual service, reviews. So in order to change this to, let's say, 0% V2, 100 to V1, all I needed to do was edit, save it, and now if I show you this, I always get the red arrow, red stars, and this should also show 100% eventually, so in about 1 minute. And that's not we don't have that much time. So thank you very much. Oh, one more thing. So basically, Jaeger, Kiali, Prometheus, Grafana are not part of Istio. They are part of the Red Hat's version of Istio, right? So if you want to get started with all of this, you can just run Maestra, which is the open source version of the OpenShift Service Mesh, and you can get it here. It's really easy to install, and that's it. I think that's it. Thank you very much.